With how advanced AI is, you probably think that all the magic behind it is a bunch of complicated algorithms. But what if I told you that it all boils down to one simple rule of finding a downhill slope, taking a step, and repeating? It sounds almost embarrassingly simple, but that's what's powering stuff like ChatGPT and DeepSeek. The learning in AI is really a lot simpler than you think. Picture this. You're a hiker stranded on a massive mountain in thick fog, and your mission is to find the valley's lowest point without a single sense of direction. All you can do is walk around until you find the way, and that's what AI is doing. So the strategy is, feel the deepest downhill slope beneath your feet, take a small step in that direction, and repeat until the ground stops sloping down. And that's called the gradient descent. AI can't just think, so it trips downhill millions of times until it finds the bottom. But don't let the simplicity fool you. The math powering is actually seriously sophisticated. Now swap that mountain for the real thing, the lost landscape. When an AI predicts something wrong, the loss is like a determiner for how wrong it is, like playing a game of hot and cold. A higher loss is colder, and a lower loss is warmer. For every step, the AI calculates thousands of partial derivatives using multivariate calculus. That's a process called backpropagation, and that's how the loss is calculated. Imagine every possible setting in the AI's brain located on a multi-dimensional map. Hills represent terrible predictions, and valleys are near-perfect answers. Linear regression models use this to nudge their parameters like slope and intercept, so it's parameter equal to parameter minus learning rates times the gradient. A gradient descent isn't some genius thing. Its power is only apparent when it's repeated relentlessly. A model like GPT-4 doesn't just navigate a single mountain though. The scale of the mountain is huge, with countless dimensions. And that's not to mention local minima, which is like false valleys that trick the AI into thinking it's reached the bottom. But that's where the speed of computation comes in. The AI performs billions of calculations per second, skyrocketing the speed of the process. That's why this method is so simple yet effective. Once this rule is run at a crazy pace, the AI ends up learning things it never explicitly intended to, because it reached a point so low that it mirrors the underlying reality. So combine gradient descent with some other optimizers that tackle local minima, and the AI becomes much more powerful.